In this video from ITFreeTraining, I will look at how to configure ISATAP in Windows. ISATAP is a transition technology for IP6 which allows internal IP4 networks to connect to IP6 internal networks. To start with, let's have a look at the network I will be working with. Here I have an IP4 network and an IP6 network. On the IP4 network, I have a Windows 10 computer running only the IP4 protocol. On the IP6 network, I have a Windows 8.1 computer running the IP6 protocol only. You can see the challenge now is to allow both computers to communicate with each other. I could have used Windows 10 on both computers, however, using different operating systems I think makes it easier to follow during the video which side of the network I'm referring to. To connect both networks together, I need a router. This router will be running Windows Server 2012 R2 and configured to use the ISATAP transition protocol. This router will have an IP4 and an IP6 address on each network. This Windows router will essentially provide the bridge between the two networks, allowing both computers to communicate with each other using the IP6 protocol. The administrator could also use Linux or a hardware router. To make all this work, I need one more server. This is a DNS server on the IP4 network. This allows the IP4 client to find the ISATAP router. To start with, I will have a look at how my Windows 10 computer is configured. This computer only has the IP6 protocol configured. To show this, I will right-click on the Start menu and then select the option Network Connections. This will show all the network adapters that are currently configured on this computer, which there is only one. To show the configuration of this network adapter, I will right-click the network adapter and select the option Properties. Notice that if I select the IP4 protocol, it is ticked and thus enabled. If I now press the Properties button, notice that a static IP4 address has been configured. If I exit out of here and select the IP6 protocol, notice that this protocol is not ticked and thus not enabled. This is one of the fundamental points to remember with ISATAP. The IP6 protocol is not required. However, once ISATAP is running, an IP6 address will be allocated to this computer. Notice this IP6 address. The computer will communicate using that IP6 address with other IP6 computers. This will all be done with the IP4 protocol enabled and the IP6 protocol disabled. In other words, using an IP6 address, IP4 will be used to tunnel IP6 traffic over the IP6 network, and then it will be routed to the other IP6 computer. This will make more sense later on. For the present, for this computer, remember that IP6 protocol is not required and thus has been disabled. The administrator could leave the IP6 protocol enabled, but I have disabled it in this video to show that IP6 traffic is being routed using the ISATAP protocol. I will now close out of here, right-click on the Start menu, and then open a command prompt. From the command prompt, I will run the command IPConfig. Notice the adapter Tunnel Adapter ISATAP. This is installed automatically on Windows and does not require any additional configuration on the client. Notice at this time that media state is currently media disconnected. When ISATAP is configured, Windows will automatically connect the ISATAP router once the configuration is completed, which we will see later in the video. The ISATAP adapter will be changed to Connected. You can see how the Windows 10 client does not require any configuration. It is up to the administrator to enable or disable IP6. We are lucky that the Windows client does all the hard work for us, connecting the ISATAP tunnel as required. Some work is required to configure the router. Before I look at that, I will look at the configuration of the Windows 8.1 client. Like Windows 10, I will right-click on the Start menu and select the option Network Connections. There is only the one network adapter installed on this computer. I will right-click on this network adapter and select Properties. Notice that if I select the IP4 protocol, this is not ticked and thus not enabled. If I next select the IP6 protocol, this is enabled, and I will press the Properties button to have a look at the configuration. Notice that no configuration has been configured. The configuration of this computer will be obtained automatically from the network. It is possible to use a static IP address, however, in this case, automatic configuration will be used. If I exit out of here, I will next open a command prompt. From the command prompt, I will run the command IPConfig. The point to notice here is that, unlike the Windows 10 client, there is no ISATAP adapter listed. ISATAP adapter requires IP4. Once IP6 is configured on this computer will access the network like any other IP6 computer. You can see, like the Windows 10 computer, additional configuration is not required other than assigning it an IP6 address. So far, I have not configured anything. I have just looked at the configuration on the Windows 10 and Windows 8.1 computer. For the next step, I will configure the Windows Server 2012 R2 to work as an ISATAP router. The Windows Server has only had the basic Windows Server 2012 R2 install performed. It has not been added to the domain. The only configuration that has been performed is to configure the network adapters. To have a look at this, I will right-click the Start menu and select the option Network Connections. There are two network adapters installed on this computer. One will be connected to the IP4 network, and the other will be connected to the IP6 network. It is also possible to achieve the same result by only having one network adapter. I used two network adapters to make it easier to understand what is happening. To start with, I will right-click on the first network adapter and select Properties. Once the properties have opened, notice that if I select the IP6 protocol, this protocol is not ticked and thus not enabled. Under this, notice the IP4 protocol is ticked and enabled. If I press the Properties button, notice that the adapter has been manually configured with an IP4 address. I will now exit out of here and open the properties for the second network adapter. Notice that the second network adapter, the IP4 protocol, is not ticked and thus not enabled. Above this is the IP6 protocol. This is ticked and thus enabled. I will now press the Properties button to open the configuration of the IP6 protocol. Notice that an IP6 address has been configured for it. It is also possible to use a dynamically assigned IP address, but since this server acts as a router, I will use a static IP address. The next step is to enable this server for routing. This needs to be done by changing a registry key. To do this, I will close all these windows, and then right-click on the Start menu, select Run, and then run regedit. The registry key that I need to change is found under HKey Local Machine, System, Current Control Set, Services, and then under the container TCP/IP. In this container, I next need to open Parameters. This contains the registry key I need to change. The registry key I need to change is IP-enabled router. You can see that the default option of this key is 0. This means the routing function on this server is disabled. To enable it, I need to change the value to 1. Since ISATAP performs routing functions, this will need to be enabled regardless of if you use one or more network adapters. Now that the change has been made, I will close out of regedit, close the command prompt, and then right-click on the Start menu and reboot the server. It is important to do this step after changing the registry key. This is because enabling routing on the server changes a lot of things, and most likely the index number for the network adapters will also change. These index numbers are used in the commands that I will need to run to configure the router. Now that the server has restarted and I have logged back in, the next step is to open a command prompt. The first command I will run is netsh followed by the parameter interface. netsh is a command line script tool that allows the administrator to make changes to network configurations. The interface parameter allows the administrator to specify which interface they want to make changes to. In this case, I want to make changes to the IP6 protocol, so I will enter in IPv6. Following this, I will enter in the parameter show. This will indicate I want to view configuration. The last parameter I will enter in is interfaces. This will indicate that I want to show the configuration of the IP6 interfaces on this computer. Once I run the command, notice that different IP6 interfaces are shown. The one that I am interested in is the network adapter that is connected to the IP6 network, which is the last interface shown. For future commands, I could type in the name of the network adapter, in this case, IPv6 network. However, it is easier to enter in the interface index, which is shown on the far left. In the case of this network interface, the index is 15. The next command that I will run will configure the network adapter to forward traffic. The server has been configured to allow forwarding between interfaces. However, each individual interface also needs to be configured to allow forwarding before routing of data between interfaces will occur. To do this, I will run netsh again, starting with the same parameters as before. Then, interface followed by IPv6. The next parameter I will add is set, which indicates that I want to configure an option on the interface. The next parameter I will enter in is interface. Since there are multiple interfaces, we need to specify which one to change. So I will enter in 15, as this is the network interface index that I want to make the change to. Following this, I need to enter in the options that I want to change. To enable forwarding, I will enter in forwarding equals enabled. This will allow the interface to forward packets to other interfaces. Essentially, this interface will forward packets to the ISATAP interface, but more on that later in the video. The next parameter I will enter in is advertise equals enabled. This option advertises to nodes on the network that this interface has routing capability. In a moment we will see how this works. The command does not take too long to run. The next step is to add a route to the computer. In this case, since an IP6 address has been configured on the network adapter, the route does not need to be added, as it will be added automatically. However, I will add the route for the sake of completeness. You will need to perform this step if you do not configure an IP6 address on the network adapter. The next command starts the same as the others. netsh interface IPv6. To add the route, I will next add the parameters add route. Following this, I need to add the route I want. In this case, the network prefix for the network. Next, I need to enter in the interface ID of 15. The last parameter I need to enter in is publish equals yes. This parameter will advertise the route on the network. You will notice that when the command is run, a message will come up indicating the route already exists. This is to be expected. However, you now know the command to use if you need it. That is some of the configuration completed for ISATAP, but not all. Let's have a look at what has been done so far. The ISATAP interface has not been configured yet, but what has been configured is the IP6 network on the server. To have a look at the effect this has, I will go back to my Windows 8.1 computer. Previously, this computer did not have a valid IP6 address. If I run IPConfig again, notice that now the computer has a valid IP6 address. What has happened is the Windows server has advertised a network prefix for this computer to use. You can see the network prefix is the left part of the IP6 address. So essentially, the computer has been configured to automatically obtain a valid IP6 address. This could also be done statically. That is all the configuration that is required for the Windows 8.1 computer. The Windows 8.1 computer has been configured with a valid IP6 address and the network adapter connected to the IP6 network. This means the Windows 8.1 can communicate directly with the ISATAP router. The next step is to configure the IP4 network on the ISATAP server. To do this, I will go back to the Windows server. There are a few more commands to configure the ISATAP network to work on IP4, but nothing too complicated. The first command starts off just like the previous commands I ran. netsh interface IPv6. Following this, the parameter ISATAP needs to be added. This will indicate that parameters in ISATAP are to be configured. The next parameter is set to indicate that an option is being configured. Following this is router, indicating a router is being configured, and lastly, the IP address. This line essentially means configure this IP4 address of the ISATAP router on the network that will receive ISATAP traffic. To better see what has happened, I will run the command IPConfig. At the bottom, notice the ISATAP adapter has an IP6 address that ends with the IP4 address that I just configured. This is the same as the IP4 address that was configured on the network adapter that connects to the IP4 network. ISATAP will use the IP4 network to route traffic between the two networks. For the next commands, I need to make changes to the ISATAP adapter. The easiest way to do this is to find the network index. To do this, I will run the same command that I ran earlier in the video, that is, netsh interface IPv6 show interfaces. It may seem strange not to use the IPv4 parameter. However, remember that ISATAP uses the IP4 protocol to transfer IP6 packets, so therefore it is considered an IP6 adapter. Once the command is run, notice the lengthy name to the right of the ISATAP adapter. A bit difficult to type in with all the random numbers in it, so like before, I will use the index number on the left, which in this case is 13. The next command is the same as I ran earlier for the IP6 network. The first part of the command says to configure an IP6 interface, and this interface will be the one with network index 13, which is the ISATAP router. The next two parameters are the same as done previously in the video for the IP6 network. Forwarding will be enabled, and advertise it is enabled. Once this command is run, the ISATAP adapter will be configured to forward traffic between the interfaces and also advertise information to nodes on the network. The next command is again the same as the one I ran before on the IP6 network. Like before, a route is being added to the adapter. Unlike before, this route will not exist, so this command will need to be run. In order for the ISATAP clients on the IP4 network to operate, they will assign themselves an IP6 address. For this to occur, they will need a network prefix. Running this command allows the ISATAP router to advertise a network prefix for the ISATAP client to use. Later in the video, we will see how this occurs. There have been a few changes made on the server, so I will now reboot the server so the changes will take effect. You will be happy to know that is all the configuration that is needed on the Windows Server to make it a fully functioning ISATAP router. However, there is still some more configuration that is required to be done before the IP4 network and the IP6 network can use the ISATAP router to communicate with each other. The last configuration that is required is to allow IP4 clients to find the ISATAP router. To do this, I need to make some changes on the DNS server. All that is required is to create one DNS record. However, we will see that process is a little more complicated. On this network, my DNS server is my domain controller that you may remember from other videos as NYDC1. You don't need to install DNS on a domain controller. It can be on a member server or standalone server or a Linux DNS server. To perform the configuration, I will open Server Manager. Once Server Manager is open, I will next select DNS from the left-hand side of the screen. This will show all the DNS servers that Server Manager knows about on this network. In this case, it will only be the local DNS server. To make changes to DNS, I will right-click on the server and then select DNS Manager. Once DNS Manager has opened, I will expand down until I reach the ITFreeTraining.local forward lookup zone. To create a new record, I will right-click on ITFreeTraining.local and then select New Host. For the new record, I will enter in the name ISATAP and the IP address of my ISATAP server. Once I press Add Host, the new record will be added. You can see the process of adding the record is pretty easy, but unfortunately, it is not that easy. To show why, I will close DNS Manager and then open a command prompt. Once the command prompt is opened, I will attempt to ping ISATAP. You will notice that the request for ISATAP could not be resolved. This is strange since I just created the record for it. What has occurred is By default, the DNS server will not resolve requests for the record ISATAP. Most people believe Microsoft has done this in case an administrator names a computer ISATAP. This could be done by accident or by a person attempting to compromise the network. If this were to occur through processes like dynamic update, a DNS record could be created on the DNS server called ISATAP. This could potentially cause problems on the network. Microsoft has disabled resolving the ISATAP record unless the administrator enables it, thus preventing accidents like calling a computer ISATAP without realizing the effects this may have on the network from occurring. So, how does the administrator allow the ISATAP record to be resolved? To do this, a registry change is required. To do this, I will now run regedit from the command prompt. Once regedit has opened, I will expand through HKey local machine, System, Current Control Set, Services, and then open the container DNS. In the container DNS, the key that I'm looking for can be found under the container Parameters. The registry entry I'm looking for is Global Query Blocked List. If I open this, you will notice there are two entries in here. These are WPAD and ISATAP. WPAD is used by Web Proxy Auto Discovery Protocol. This allows clients to locate a proxy server automatically on the network. It is blocked by default, as it is possible for an attacker to use dynamic DNS to create a WPAD DNS record pointing to their own server and capture all web traffic. ISATAP is blocked as well, most likely to prevent issues if an administrator calls a server ISATAP or an attacker uses ISATAP to access network traffic. To allow ISATAP to be resolved, I will remove the entry ISATAP from the list. Notice that once I press OK, I will receive a message indicating the empty strings are not allowed and will automatically be removed. Essentially, this is saying that empty lines will be removed. That is fine, so I will press OK. I will now close DNS Manager and go back to the command prompt. Changes have been made to the DNS server configuration. For these changes to take effect, the DNS server needs to be restarted. To do this, I will run the command net stop DNS. Once the DNS server has stopped, I will start the DNS server up again by running the command net start DNS. The DNS server will not take too long to start up, as there are not too many zones and DNS records on this server. Once started, I will run the command ping ISATAP a second time. Notice that like the first time, the DNS record will not be able to be resolved. It would appear the change has not taken effect, but I have come across this problem before and know the solution. The problem is that the DNS cache contains the previous DNS resolve request, that it was not able to resolve the DNS record. The cache will need to be cleared before it can be resolved. To clear the cache, all I need to do is run the command IPConfig/flush DNS. Notice that if I run the ping command a third time, this time the DNS record can be resolved and a response is being received back from the ISATAP server. This completes all the configuration that is required for ISATAP. ISATAP is now ready to go. You could take my word for it that ISATAP is working, but let's have a closer look at it working. To do this, I will go back to my Windows 10 computer. On the Windows 10 computer, notice the output from the last time I ran IPConfig is still on the screen. Notice that ISATAP tunnel is listed. Currently, ISATAP is shown as media disconnected. IPConfig was run before ISATAP was configured on the network. So notice what happens when I run IPConfig again. Notice that the ISATAP router is listed just like before. However, notice instead of saying media disconnected, it is instead displaying an IPv6 address. This was done by the client automatically. This should happen by itself given enough time. However, if you want to speed up the process, you can disable and enable the network adapter on the computer or restart the computer. Let's have a closer look at the IP address to understand how ISATAP works. Shown here is the layout of an ISATAP address. It starts with any network prefix, followed by a fixed section. This will always be the same value, which immediately identifies it as an ISATAP address. Following this is the IP4 address of the ISATAP client. For example, in this case, it will be this computer's IP address. If, however, you were attempting to contact the ISATAP router, the ISATAP IP4 address would be used. To demonstrate this a bit better, let's break down the ISATAP IP6 address of this client. The first 64 bits of the address are shown. If you remember, back when I configured the ISATAP adapter on the Windows Server, this was the route that I added to the server. All computers on the IP4 network will use this network prefix when they configure an IP6 address using ISATAP. The next part of the address will always be the same. As soon as you see 5EFE in this part of an IP6 address, you know straight away it is an ISATAP address. The last part of this address is the IP4 address for this computer. If an IP6 computer wants to contact this computer, it just needs to use this address. Now the exciting part. Let's prove that ISATAP works. To do this, I will ping the Windows 8.1 computer using its IP6 address. Notice that when the command is run, just like a lot of things in computing, it does not work as expected. No response is received from the other computer. The problem is not that ISATAP is not working. It is that the other computer's firewall is blocking the ping request. So the next step I will do is allow pings to this computer so the Windows 8.1 computer will be able to ping this computer. To make the change, I will search for Windows Firewall and then select Windows Firewall with Advanced Security. Once open, I will right-click on Inbound Rules and select the option New Rule. From the New Rule wizard, for the rule type, I will select Custom and press Next. On the next screen, I need to select the protocol type, which I will select IPv6. It will seem strange to select this option since this computer is connected to an IP4 only network. However, the way it works is ISATAP uses a tunnel over the IP4 network to transfer IP6 packets. So when the packet arrives on the computer, it is an IP6 packet, even though it went over an IP4 network to get here. On the next three screens, I don't need to configure anything, so I will press Next until I get to the last screen of the wizard. On the last screen, I will enter in a name for the rule, and press Finish, and close Windows Firewall. This computer has now been configured to accept pings from other computers. The next step is to test out the connection to the Windows 10 computer. To do this, I will go to the Windows 8.1 computer. On the Windows 8.1 computer, I will attempt to ping the Windows 10 computer. To do this, I will use the IP6 address that is assigned to that computer through ISATAP. The first part of the address will be the network prefix. All computers on the IP4 network using ISATAP will start their IP6 address with this network prefix. The next part of the address is the fixed part of the ISATAP address. This will always be the same. Following this is the IP4 address of the Windows 10 computer. Once I run the command, notice this time I will get a response back from the other computer proving that ISATAP is running. To summarize what has happened, this computer has IP6 only with a valid IP6 address. It has sent a ping request on the IP6 network just like it would have to any other IP6 computer. When the request reaches the ISATAP router, it is placed in an ISATAP tunnel and transferred over the IP4 network until it reaches its destination. Now it is time to test the other direction. To do this, I will need to make changes to this computer's firewall. To do this, I will right-click on the Start menu and select Search and search for Firewall. I will then select Windows Firewall with Advanced Security. Once opened, the procedure is the same as the Windows 10 computer. Right-click Inbound Rules and select New Rule. From the first screen, I will select Custom and then press Next. On the next screen, I don't need to assign this rule to a program, so I press Next. On the next screen, I need to decide which protocol I want the rule to apply to. Like before, I will select ICMP for IP6. Once selected, I will press Next. The next 3 screens I do not need to configure anything, so I will accept the defaults and press Next until I reach the end of the wizard. On the last screen of the wizard, I will enter in a name and press Finish to complete the wizard and close the Windows firewall. This computer will now respond to ping requests received from other computers on the network. The Windows 8.1 computer firewall is configured, so now the last step is to go to the Windows 10 computer and test the connection from it to the Windows 8.1 computer. On the Windows 10 computer, I will retrieve the last command and run it. Notice that this time I get a response back from the Windows 8.1 computer. This shows that ISATAP is working on both computers. There has been a lot covered in this video, so I will perform a quick summary of the main facts. To start with, a Windows 10 computer is configured on the network that is configured to use only the IP4 protocol. ISATAP will provide this computer with a valid IP6 address that it can use to communicate with IP6 computers, and other IP6 computers can use to communicate with it. It will do this by using a tunnel to send IP6 packets over the IP4 network. On an IP6 only network, a Windows 8.1 computer is configured. This computer will only be configured to use IP6. It will communicate with the Windows 10 computer with the IP6 address provided by ISATAP. To make all this work, a Windows server is placed so it can access both the IP4 and IP6 network. This needs to be configured for ISATAP, which there are a few steps to make this happen. First, routing needs to be enabled. Since this changes a number of other things, a restart is required. Next, the IP4 and IP6 need to be configured to forward traffic between interfaces and advertise on the network their network prefixes. After this, a route is added so traffic will be transferred across the network correctly, and also so that nodes on those networks will know which network prefix to use. Next, the router needs to be configured with the IP address that it should listen for ISATAP requests. Lastly, the server needs to restart. That's it for the ISATAP. The point to remember is that it is a transition protocol designed for internal networks to provide a bridge between IP4 and IP6. It has been quite a long video, and if you've made it this far, I would like to thank you for watching. I hope to see you again in other videos from us.